All right, well, this is the new camera, and we'll see how well it works. Here's how it does on blow up. That's not too bad. Seems to be considerably better than what I had before. Anyway, I did go through the voltage checks. Everything seemed to make sense for the most part. And so there's no voltage on a grid that looks like a plate or anything like that. And there shouldn't be, considering that we passed the DC checks. But anyway, we're cautious. So it's now up to 90 volts. And we're going to go through again and record these values. I'm just going to do one tube on camera. Start with pin 1, should be 0. Yeah, that's essentially 0. Pin 2 and 7 are the same. You can see them connected together, 1.5. So that's good. That's partial up to what it would be at full power, 2.4. We're not measuring the filament. We're looking at the plate on pin 5. 143. We're not going to measure the other bands. We'll wait till we're at the full power. And 165 for the screen. 138. 165 will be at full power. All right. So we'll just walk through the tubes again and do the measurements. So I went through, there were several tubes that had to be removed in order to be tested. And so I made it through the 90 volts without any issues. And now I'm going to move it up to 120. And let's see if we hear anything. I can actually turn on the volume. Now, this is a speaker that when I was putting in the spider, a big glob of super glue got all over the place, so it's not a properly functioning speaker, but it makes a noise. By the way, it's 1,000. Oh, I don't know what I tuned. I didn't tune this to 1,000. Here it goes. Well, there's something going through anyway. Oh. You set the controls. AM, off. Band 1. Okay. I'm hearing something through this pitiful speaker. Actually, I have a good one. All right. Tubes are in place. Yep, the tube's making the heat. Let's get a real speaker. We'll be back. And the mic off. Here it's on normal. Okay, we'll try that again. I've done I've done the voltage checks at full power. It's at full power right now. And I put the tubes back in that had to go in order for the radio to operate. But I have the speaker is so bad that I need to get it better, and I found one that I can use. So we'll get that taken care of. And we'll come back. Okay. So got the volume up. There's no S meter action. There is sound. Some sort. So it's in RF somewhere, and we're just going to have to hunt it down. And we'll get the oscilloscope out and find out where I made my mistake. But first I will finish out these voltage checks at 120 for the record, and then we'll call it a day. So we'll have to do that, and then we'll come back. So I finished doing the voltage checks, and I got curious why there's no signal getting through. So I got a chance here to use my Heath kit. It's hard for me. I'd have to move the camera to show it, but it's behind this. I'll show it at the end. My rebuilt Heath kit signal tracer. So we got our signal. Let's get our signal in. Where'd it go? All right. Yeah, it's plugged in there. So I mean, if you go to this. Okay, signal's getting through the antenna section. I'll just go to the pin 1 is always a cathode. It's getting there, okay. Now we're at the first IF. It's overwhelming now. All right. We just tune in. Let's do this. Yeah, there it is on the first IF. Then we go into the mixer box right here. Something good there, okay. We come out of the mixer box here. But That goes into the filter, and it should come out right here. It's really hard to get this to work right. No signal. Okay. So somewhere in the filter box, and where do you think it might be? Could it be these have all been screwdrivered way out of... I can't even get them to turn, they're so tight. Oh no, it's not that. So the signal comes in here to pin 1. Okay, and then it comes out right there. Okay, but on this side, nothing. Nothing. There should be a signal coming through on this side. There is a signal coming through here. Very interesting. Bad cable or bad cable installation? Well, we'll have to examine that tomorrow. So on one end in the filter box, I had signal, but then right here, turn that noise off without touching anything. Right here is pin 1 of this 6BA6, and I'm not getting anything. The tube is quite hot. Okay. Tomorrow, and we'll have to explore that. Okay. So, when I put it all together, I was not getting any signal to the audio signal. And so somewhere in the RF section that was a problem. So I used this ETH kit signal tracer that I put together, and I just wanted to demonstrate how that's done. I'm turning up the gain now. So it's a pretty hummy device, but you simply put this at the input or the grid first, the RF tube, and then I did the same there. It's hard to get in there with this right now, but here's another one, the first IF tube, just right over there. But when I came to the grid of the here we go. Right, when I came to the grid of the second IF tube after the filter box, there was no signal here. There was signal coming in here, and there was signal going out here, but actually there was no signal going out here. So I went back and traced in the filter box and found that Alberto reversed the input and the output from the filter box, and of course that's where the signal stopped. So that so it's just simply, you don't even, you can use an oscilloscope. You can I would guess an oscilloscope would probably be another way of doing this, just as easy as this. But that is an idea of how a signal tracer can work. Now we get anywhere close to the detector, we're getting the signal. You get anywhere near the audio amplifier, and you get it. Let's see this right here. There you are. And we're not going to the output tube for that. So, problem solved. We'll turn that off for a second here. And that's my signal generator at 1,000 behind it. We'll turn that off. And turn the volume up. Let's get this off. There we are. Oh, sounds like a radio. Sounds almost like it did.
Would normally go to the first.
Lots of signal. Okay, so that, it's been debugged. The problem was me, but it's easy to find with a signal tracer, or oscilloscope would have done the same thing. I verified that it was reversed with just a VO with a ohm meter, and it was not continuous to where it should have been. And let's see what else. Oh, on the S meter, the screws which tighten in on the S meter needed to be almost torqued to get good signal to the S meter. For some reason, that's always been the case. And so when I got it real good and tight, then the S meter working properly. So we have an operating set. It's ready for, really, it's ready for alignment. That's going to be a huge setup. I'll take it in the other room. This radio is safe for operation without a variac. The voltage is all checked out. The signal is verifying everything's working, so we can move on to the next step. And I don't know if I'll have a chance to get all that set up today or tomorrow. I probably will tomorrow afternoon. And just at least give an image of what the visual IF signals look like from the spectrum analyzer. And hopefully I can find the ones that were done before the restoration, and we can make a comparison. All right, I'm having to hold this by hand. I'm using a macro lens on my new camera. That's nice. In the center of the picture, you see a yellow wire connected to the yellow wire from inside the filter box, and the green wire connected to the green wire inside the filter box. And I'm going to turn this off a second and talk about it without the macro. So what you're looking at is a it's like I didn't charge the battery like I was supposed to, so we have to go quickly. What you're looking at is a new terminal strip that I installed specifically for the purpose of making it easier to take the filter box, the mixer box. I keep calling it filter box. This is the first
second IF mixer box. Make it easier to get it off and on the set because of my experience in taking it off 5 times in the other set. So I'm sitting there and I'm running the, looking at the alignment and adjusting things, and nothing's happening. And then, well, I was watching, listening to the radio. Yeah. Well, I normally have the radio on the normal position, which is upper sideband. Upper sideband is inside this hole is the bottom side of T9. Well, when I put it to lower sideband, nothing happened at all ever. So after a while, even I figured out that I got the yellow and the green wire reversed, and I've got a lower sideband or the function switch at upper sideband and no real upper sideband. So because I did this terminal strip, this will be an easy fix. So that's what I'll do right here. I'll just pull a soldering iron and pull those out very quickly, supposedly, and switch those around. And the other thing is, somebody may be confused by that in the future. So I've got some sleeving, colored yellow sleeving I'll put over the green that comes out of the box. And I'll literally paint the yellow green so that green will be connected to green in the new. At least that's my plan anyway. We'll see how that works out. But at any rate, that's the way it works. So I'll be back after I made those fixes. Well, that was it. I've got now upper sideband and lower sideband. I had this uneasy feeling that I may have gotten those insulated wires backwards coming out of that box. So easily found, something to remember. And I couldn't really get the sleeving to get onto that yellow wire, so I just painted it with my green Sharpie as best I could at the point. So we've got here the yellow and there the green, and that's the new yellow and the new green, so that we have both upper sideband and both lower sideband. I thought I had a charged second battery here, but it turns out that they had a piece of film over it, so it wasn't charging. So I've kind of run out of time on the backup battery. But at any rate, we have a fully operational radio, and then we'll try to do the alignment stuff tomorrow if I have the time. Otherwise, we'll close it up. But anyway, lesson learned, I guess. You go to the trouble of doing colored leads just like the schematic, and then, oh well, you know. So I've been working quite a bit this morning, and what had happened was in crossing the ground wires out of the mixer box, trying to figure that out when I was trying to find out why there was no upper sideband, and had not figured that out yet. Screwdrivered the 50.5 IF transformer. Just, is this the reason? And logic would have told me no, it isn't. But anyway, I did. So I went back and reset up everything for the 50 kilohertz, 50.5 kilohertz. Now this is probably, after a lot of figuring out things, I think this is the proper way to depict the curve at 50.5. It's actually a 3-hump curve when you sweep it. And the other key thing I wasn't paying attention to was it's supposed to be on 0.5 kilohertz in the bandwidth. So at any rate, this is what it looks like when sweeping. Basically, you have two peaks, one at 50 and one at 52 and a half, and there's about a 5 kilohertz in between. Let's see, no, one is in the middle, okay. Two is in, this is not showing everything on the table, so it's actually one at, two is at, let's try this. How do I show the whole thing? Oh, go to marker. Marker table on. Okay, there's more on this. 2 reference and 2D. Okay, 2 reference. I got you. The delta is 4.767 below 52.4. Okay, that's what we're looking at. So essentially about 5 kilohertz below, which is 47.5 and 52.5. But that's what it looks like when you sweep it. Now when you go to take the sweep off, which is what you should be doing when you're doing the alignment, this is the maximum response here. We can take the table off and just look at the marker 1. And the peak is right at 50.5. And so the traditional method actually works just fine. Here it is. Get rid of that light through. Okay. Now I've got a lot of amplitude. I've got 4 volts instead of 1. So this is on the 10 volt scale instead of the 3 volt scale. And you do it really at about 1 volt. And you can actually knock it down even to the bare minimum to just barely detectable. And it has a very, very distinct peak when at the narrowest bandwidth. So, so we're done with that. This is again the pickup for the meter is at test point B, and in the injection point is it for the signal generators at test point A on the schematic. And there's also a figure 12 in the manual that shows you where those points are. And of course I put in test point connections to make it easier to do this. So we'll take this down, put the oscillator tube back in, and look in the 1650 IFs for real with both bandwidths this time. I think I'm going to label this video Wires Crossed. Well, again, it seems that using the analog traditional method is very effective, and I was able to again realign the 1650 IFs very well. And this is just a picture. To sweep it, I just don't get a decent picture when I sweep it, so I've given up with that. So we have about a bandwidth of I can't read it now, 1600 kilohertz, and the center frequency is just a little bit higher. It's 1650 300 hertz. So the IF section I also verified by just using the radio and the receiver, and both the upper sideband and the lower sideband work very well. So we're past all the issues, I think, with crossed wires. Well, I went ahead and I've done alignments and so forth on other videos and so forth. So I'd finished the RF calibration, dial calibration, and the alignments. We still have other things to do with it, but this is enough for today. And extremely sensitive set, very good. Working set now. Do appreciate the new subscribers and the shout out from Larry from the hills of Eastern Tennessee and Back to the Future Radio is a really kind man. And thank you for watching, and we'll see you next time.